Good afternoon, everyone, and thank you very much for joining us for this session of the 6.2 oxygen release. My name is Richard Salmon, and I'll be the moderator today. Mateo Holguin is going to be doing the technical presentation. Have some housekeeping notices to go through. The first thing is to feel free to ask questions at any time during the presentation. On the web tool, there is an icon with a question mark that will allow you to enter the question. If you want to download the documents that we've provided, you can use the document icon, which looks like a page. We encourage you to scan the QR code that we now display on the screen. This will link you to our social media channels. We really encourage people to do that. We push a lot of material out through the LinkedIn connection. And at the end, there'll be a survey. We want to hear your feedback and areas that we can improve in. So as far as the format of the presentation, Mateo is going to run through a few slides talking about what the feature is, and then he's going to jump into the software and actually show how to set up the feature and that type of thing. I think that is it for the housekeeping matters. So Mateo, why don't you take over?
All right, thanks, Rich. So today we'll be talking about some of the new Oxygen 6.2 features, which will have a release date of July 15th, which is tomorrow. Some of the new features we'll be talking about, not to go over the list too much, but we're going to be talking about statistics, new import features, export features, and some new extensions for CPAD decoders, and some other miscellaneous features that could be very important for your projects. All right, so for trigger statistics, you'll be able to calculate statistics values based on triggered events, which will give you the ability to have calculation starts based on a rising or falling edge of a channel with an optional rearm. This also gives you the feature of different calculation stops. So at the end of a trigger, you can have a re-trigger, which will give you a new passing of a start triggered event. And there's also duration, which gives you a set amount of time once triggered. There's stop trigger, which trigger completes after one passing. Another new statistic feature that we have is running statistics, which gives you the ability to calculate run statistics, which inherits the sample rate of an input channel. This pretty much looks back at the window size on each new sample and calculates statistics for the look back window based on the amount of time that you have set. So now I'm going to be showing you how to set these channels up. So I'm going to open up my channels list. So first I want to talk about my actual hardware. So I actually have a Trion attached to my system, and it has two cards. I have a 1603 LV and also a Trion 2402. But today we'll be focusing on the Trion 2402 multi, which actually has a tuning fork attached to it, which is based off of a 3-wire quarter bridge strain gauge. So I'm just opening that up right here. So as you can see, I have my mode set to bridge mode. I have it to bridge quarter 3-wire with 350 ohm. I'm not get too many details, but it's the specifications of the strain gauge. Close that out. And to create these channels, you're actually going to select the channel that you want to base the statistics off of, and you're going to click the plus icon on the bottom left of your screen. Once you have that selected, you're going to notice over here that we have a bunch of different options of different channels that you can create based off that channel. We're going to click statistics, and you're going to notice that there's a bunch of different options of different statistics you can do, such as average, max, and min. For the example, I'm just going to select average for the demo purposes, and then under calculation type, there are different two new options. So there's triggered and running. So I'm going to click triggered, and just know for the trigger, you don't have to use this specific channel to create the trigger. You can base the trigger off of another channel. So if you have some sort of motor or anything like that you want to hit a certain voltage or RPM, you can have this trigger start for this channel. But for this system, I'm going to be using this channel specifically. So I'm going to use the same one. And over here, you'll be able to select your trigger level. So I'm going to type 0.4. And I'm going to base it off of the rising edge. Over here, we have a rearm level, which is optional, but it's very recommended just to keep a stable data coming in. So I'm gonna do 0.2. And then over here, we have our stop mode. I'm gonna click duration, just so the duration of it, it's gonna continue. So we're gonna do 1 second duration after the trigger. For the group name over here, this is gonna group all your different statistics channels. So I'm gonna name it triggered. And what you'll notice is at the top over here, we have created a new channel under triggered. And because I already had another trigger channel already created, it will categorize them under the same name.
Hey, Mateo, just a quick question popped in from the crowd.
Yep.
For defining what you're triggering off of, it doesn't have to be a statistics channel, right? It could be an analog input or anything.
Yeah, so it could be based off of analog input. It could be any of your channels that you have pretty much imported onto this channel list. And you can create that form based on that. Yep.
Okay, excellent.
So now I'm gonna create the running statistics. So I'm gonna click the plus icon, same way, statistics, average, and then I'm gonna go to running. So running has a little bit less options. So over here for the running statistics, it's gonna base your statistic, whatever you select here. So I'm gonna have a running statistic of a window size of 1 second. So pretty much get my average of each second. And now I'm gonna give the same group name, running. And then you'll see under the category of running, I have two new channels. Oh, another new channel over here. Cool. So now I'm gonna close that out. And so I already created a measurement screen over here. So I have 3 recorders onto the screen with also 3 digital meters just to be able to show the values of what is coming in live. At the top, you can notice the tuning fork, which is based off the strain gauge. The middle is going to be the triggered of the tuning fork statistic. And then we also have the running statistic for the tuning fork as well on the bottom. So if I squeeze onto the strain gauge or the tuning fork, you'll notice that we get some data coming in. Or if I tap onto it, there you go. So with that being said, we also have, just to let you know, this is separate from the triggered events menu right over here. So pretty much the triggered statistic is its own channel. So it's its own trigger, which is separate from the actual triggered events right over here. With my triggered events, I actually have it set to be able to, once I hit a certain level of frequency, it's gonna, voltage, it's gonna start a recording. So I'm gonna arm it right over here, arm trigger. And then what that happens, I'm just gonna tap on it. And then you'll notice that it started a recording. Once that goes down, I'm gonna stop it. Boom, perfect. So now I'm going to, once that finishes downloading, I'm gonna open up that data file. Open up here, I'm gonna save this. So just to let you know, so we were in a live mode, which is also the recording mode. And you're gonna notice at the bottom left of your screen, there's a circle that shows the software mode. So when it's grayed out and it says live, that means we're in live mode and we're not recording. So it's just live data coming in that you'll be able to visually see. And then when it's red, you'll notice that it says recording in it. And that's when you are in recording mode. So you're in live mode, but also recording. Now I'm in Oxygen Viewer. So pretty much I have a recorded data file open. And to know that you're in that mode, you're gonna notice this green bar as well as the green circle button at the bottom left. This pretty much means that you're viewing data, but please know you can have a live mode or recording mode open in the background with another instance of Oxygen open. So you can have multiple. So over here, you'll notice that we have our data here. So I'm gonna open this up. So I can open my data. You see that we have the red statistics over here because it's averaged out and it was a frequency. It's just gonna zero out. And then when I open this one, so I'm gonna track this. Let's see. Open to overall min max. Interesting. Looks like we're gonna need more data points on that one. But because it's a test, so that's why we continue on with another test. So there you go.
Yeah, you probably had your window set too tight to really show
Yeah,
the data.
exactly. So you want to make sure you have your window set larger to be able to see your data points. But because it is an average of the 1 second and it's fairly quick, you're only gonna get that 1 point. So I'm gonna click eject here. And actually, yeah, let's do that. This card. Cool. So now once you hit eject, it is now going to be opening up a your live mode once again. So over here, you're going to notice that you have everything back to normal. I'm just going to open up my screens over here. So now we also have some new import and export features. So we have a CSV file import, which gives you the possibility to import CSV files in play mode. This will allow you to have time alignment. So pretty much in the first column of your spreadsheet, you have an absolute or relative time, but there's no time included. You can have a synchronous sample rate, which can be defined. And there's also an optional data offset in relative absolute time, which can be defined. So you can align your data as you please. So, and then for our new export feature, we do have NetCDF export format, which I'll be showing you how to get to that. Which is a network common data form, which is a file format that supports creation, access, and share of sensitive data. We have 3 different options of this file format. We have NetCDF3, NetCDF4, which is an HCF5, and we also have NetCDF5. So I'm going to be opening up a file over here. So while you have File Explorer open, you can open up another instance of Oxygen Viewer, so you can have everything in the background still open, which I'll be doing over here.
So you just went into File Explorer, went into the data file, found the file you wanted open, and just opened up a viewer package.
Yep, exactly, Rich. So that's what's pretty much open now. So while I still have this one open, so this is the Oxygen Viewer mode, so the player mode. It does not affect what's happening in the background. So if I am recording a project or if I'm recording any sort of test, my system is still doing that in the background while I'm still able to look at data from a previous project in case I want to compare anything that's going on. So as you can see over here, this is the recorded file that we have opened earlier. And yeah, so first I'm going to be showing how to do the whole import feature of the CSV file. But first, I want to actually export a CSV file. So I'm going to open up my export screen over here. I'm going to select the tuning fork channel. And over here, you're going to notice a CSV export option. I'm going to keep everything defaulted over here just so that way when I import, I can keep those settings defaulted so everything just transfers over smoothly. So right over here. And once you have the channel selected, once you have the channel selected and you have the CSV, you'll be able to export your file. So once you have that, you're going to open up your data channel. You're going to select the plus icon right down here. And then you're going to notice under data sources, you're going to see CSV import. Once you have that selected, it will say select a CSV file that you want to import. So select that. And you're going to go to the folder that you actually had it exported to. So I'm going to go to Documents, go to Webinar, and then select the CSV file that you exported. So I'm going to click this one, which is my webinar test. Open that up. And then I'm going to select this to relative time. And on the bottom, you're going to notice pretty much a snippet of your spreadsheet of the data that you're going to be importing. So right over here, you just click Add. I'm gonna close this out just so I can show the channel list. And you're gonna notice right under local node, you're gonna see a CSV import grouping, and you see the webinar test CSV and the tuning fork channel. This works just like any other channel that you have imported. So if you want to use this to compare data with anything else that you already had on this file, you can do that. You can do any math formulas with it and do any manipulation or data analysis. So I'm gonna.
It's funny, we've done this presentation 3 times and I get the same question every time, that how many rows can you import? and it's just answered at 16,000 rows as far as the size of the data file.
Yeah, so you can have 16,000, yep, which is quite a lot actually.
Yeah.
So I'm gonna be pretty much gonna now put this on the instrument. So I'm gonna take away my my tuning fork trigger statistic off of this one over here. And then I'm now gonna place my the data I got from the CSV file. So I'm gonna select that here, and then for my digital media as well. And you're gonna see that the data is very similar. The only reason why it's a little bit different is because this is actually a CSV file that I exported from a previous test. So I'm comparing now two separate projects. So over here, I can actually see that my data is a little bit different, but now I can see the differences. Perfect. So now I am going to show you where you can find the new export settings. So under the same export, you're gonna scroll down and you're gonna see the NetCDF, and you'll see the 3 different options from there. Perfect. So now I'm gonna close this out. And notice how instantly I'm right back into my live mode. That's because I have not closed it out in the background at all. So when I eject, I don't have to load it up. It's already there, just in case you want to go back and forth fairly quickly. But now I'm going to be showing you a presentation from Raphael. Rich, if you have any input on that.
Yeah, this is one of the 2 videos that we stuck in the presentation. What we're making, we're just announcing our native drivers for LabView. So we'll let Raphael explain what the details are.
Perfect. Thanks, Rich.
Hello, everybody, and welcome also from my side to the new webinar series about the Oxygen 6.2 update. My name is Raphael Ludwig, and I'm the Product Management Team Leader at DEWETRON. Today, I would like to introduce the new try-on driver for LabView to you. What is that? The try-on driver for LabView is a native LabView hardware driver for DEWETRON's try-on and try-on 3 data acquisition boards. The driver allows the user to access and edit the settings of try-on and try-on 3 data acquisition boards directly in LabView, and also to acquire and to process their data in LabView. The compatibility includes LabView versions 2018 and higher in 32-bit and 64-bit mode. And the driver will be available for download on our CCC page, on GitHub, and on the NI Tool Network homepage. Who are we addressing with the driver? The try-on driver for LabView can be used, for example, by testbed integrators, which are programming testbed and automation systems with LabView, by LabView developers, which are developing customized and user-specific software solutions, or also by universities, which are using LabView for research and for education. Last but not least, for sure, the driver can be used by anybody else who wants to integrate data of try-on and try-on 3 data acquisition boards into a LabView environment. So much as a quick introduction. If you have any specific questions, please feel free to come back to us or to your local representative, and we will get you the required answers as soon as possible. Thank you very much.
That announcement there just gives us better flexibility in regards to supporting different software, well, the LabView software platform. So that's why we put the development effort in to introduce the new drivers.
Yeah, perfect. So thanks to Raphael and Rich for those explanations. So now going on to some of the other new features that we are having over here on the demo. We also have some extensions for the CPAD decoder. This expands compatibility for the our new XR modules, which is one of our new product lines. This is pretty much almost a direct replacement to our CPAD and EPADs. We also had the possibility to edit CAN ID types between standard or extended, extended being the default. Possibility to edit CAN address and IDs. And also we now support the export of CPAD and XR configurations into DPC files. So in case you want to be able to use this elsewhere or be able to export these files or import it, you'll be able to do that for later projects as well.
I got distracted for a minute. Did you mention that the XR modules are the replacement hardware for the CPAD modules?
Yes. Yep.
Okay. Sorry about that.
Yeah, no worries. So now we also have a very important feature that's very useful. We have now an error log list that you can access. So pretty much all your errors and warnings that you get at the bottom right of your screen, as you can see in the screenshot below, they pretty much go away fairly quickly. So in case you're not actually paying attention to the screen, or you're not looking at it, or this is a test that's going on multiple days, so you're not always at the system, you can actually access these errors and warnings later on, so you can resolve them. So to access this, you're gonna go to the DEWETRON logo at the right, unless you have it switched to the left side. But so I'm gonna open this Oxygen setup screen, and you can notice right under system information, there's errors and warnings. So whenever there's any errors and warnings over here, if I had any, they'll be displayed over here in case you want to resolve them. You can clear the errors below, or if you want to be able to escalate this issue to someone that's higher up or a technician that's at your facility, you will copy and paste these into Notepad or Word or PDF, or if you want to send it out to an email. So you can export this information, and then once it's resolved, click Clear Errors.
Sort of too bad that we didn't have any hardware compatibility issues or anything.
Hey, it's a good thing for now, right? So if there's no errors and warnings, that's a good sign. So it may not have been good for demo purposes, but it works out because makes things smoother. So now we have some miscellaneous features that would be very important for you guys or any project you guys are working on. One of the biggest ones is our ENUM scaling, which is now available for formulas. They were available for our CAN bus features. So there's an example on the right, but I'm going to show you how to actually set it up. So what this will allow you to do is you people take variables or your values from the data that you're having coming in, data streaming in, that could be your analog data or anything like that, and you will to translate that information into text. So to do that, you're going to open up your data channels, and you're going to click the, you can either select a channel, or if you just click the plus sign and create a formula. So once you have them created, so I have them created, so I'm just gonna open that up. I have a formula that I have set here just so I can convert some numbers, just for example purposes. So I have my tuning fork coming in +9, and then I go into the enum label editor, which is over here at the top right above the text box. And from there, you're gonna see there's 2 columns. So on the left side, it's value. So you have the different values you wanna put in there, and then you have label. So under label, you'll be able to type in the text you want to have represent for those numbers. So I have 1 for null, just in case I don't have any data really coming in, just noise. And then I have 9 for okay and 10 for great. So, so now with that channel, you will put that channel onto a digital meter. Usually what would happen if you put a channel on a digital meter, you would just get numbers, such as you'll see down here. And this is a digital meter over here. But because we have that label, we now have pretty much the signal or indicator that says okay. And so if I squeeze onto my tuning fork here, you're gonna see that it says great because the value went up. This is very nice for in case you have any technicians that's looking at the screen or you're doing a project, so you can have a better indication of what's going on with your project instead of just having numbers. So it's a direct translation automatically instead of having to think about it or look through it. Perfect. So now we also have FFT averaging enabled for math channel FFT channels between 1 and 16 spectra. We also now have the possibility to assign up to 40 channels to a recorder. This is nice because if you're doing a project and you're doing trend monitoring, you can detect outliers within your data. So another great feature that we have is we have a new header type, which is selection. So in case you know what headers are, is pretty much so if you are starting recording or you're ending recording, you can have mandatory fields of data that you have to input, for example, name or RPM of a motor, things like that. So with this new selection type, you can have us make it so there's only a certain selections that you can choose from for the numbers that you want to put in. So for example, if you have a motor and you only have 4 different RPMs that can be set to, there can't be any mistakes of what's typed in, or it can't be left blank, for example. So I'm going to show you how to create that. You're going to go to the top right, which is your measurement settings. Once you have that open, you're going to select header data. Over here, you're going to notice a few columns. You're going to click the plus icon right over here. And then for the type, you're going to see the new option called selection. Once you have that selected, you're going to type in the name of this selection. So I can type in motor speed as an example. And over here, you're going to notice a button right next to it. When you have that selected, you're going to see, again, a couple columns. You're going to click the plus icon. And over here, you're going to type in the different values. So for example, I'm going to type in 120 RPM. And then I can type in 250 RPM. And then I'll just type in another one over here. Let's just say 360 for rotations per minute. There you go. I'm going to close that. And then under the prompt, this is where you people select never recording start or recording stop. So pretty much what that would mean is, like I said earlier, is you can have this prompt come up before you started recording or after you finish recording. So I'm going to click recording start, and then I'll make it mandatory. So pretty much when the recording starts, it's mandatory to fill in these fields. So I'm going to close this. I'm going to start a recording over here, and then you'll see this header data pops up. And over here, you see the drop down, and there's only 3 options I can choose from, so I can't leave it blank. So I can select one, click close, and now that header data is now filled in for you to be able to view after. Let's stop the recording. So now we also have, go ahead, Rich, do you have something to say?
Well, the ENUM and the header information really give the user a lot of control on how they want to display information and how they want to control the user. So
yeah, exactly. Yeah, so this pretty much makes it so you're going from, for the ENUM, you're going from only viewing numbers all the time, because you might have different engineers, work on this project. You might have technicians, and sometimes the technicians might not know what this number might represent. So you might have something that might be a good number. You might have something that's a bad number, but it can be off by a couple of decimal places, which could be hard to tell, especially when numbers are changing fairly quickly. So to be able to see these data points, be represented in words, it'll make it much easier. And then the header data makes it easier. So in case you have multiple data files that were recorded, you can see what RPM this test was based off of, what technician was working on it, and what test number it is. So there will be no mistake in this, regardless of what the file name is, because sometimes the file name could just be a serial number, for example, or just a date. So this makes it fairly nice just to be able to pinpoint what exactly you're looking at with no confusion. So that's a really good point, Rich. Thank you. So another huge feature that we have is the export option to a lines trigger, which only works for currently the export settings of text files, CSV files, and also XLSX files. This is especially useful for when you have a pre-time. So let's say you have a trigger and you have a pre-time of 2 seconds. So when you have a trigger that happens, say you have an event like a boom on the motor, or you have some sort of event happening. So at first you see that the pre-time was going to be set to the 0 mark, and you might have confusion on when that trigger actually happened. So when you export, for example, on a spreadsheet, you see the negative numbers represented as the pre-time. So that's if you have it enabled. So the 0 is your trigger, and then anything prior to it would be your pre-time, so there's no confusion. You can actually see that as an example down below. So over here, you'll see that we have it starts at 0. On the right side, you see that it starts at -2. So -2 is actually the pre-time. Perfect. So now I'm also going to be showing you another huge feature that's really important. So if you want to slim down any large data files. So I'm going to go over here. I'm going to open up my big systems file. This is a recorded file that we already had. So once this opens up, I'll be allowed to open up my channel list and bring down my file size and save as, so I can actually send this to colleagues. What's really nice about the Oxygen software is when you have different recording files, the license is transferred with the recording files. So if you have a colleague that wants to review the data, but you don't want to show the hundreds of channels that you have, and you have 2 specific channels you want to show, for example, strain gauge or anything like that, you can show them just those specific ones. So I'm gonna open that up over here, and I'm gonna open my channel list. And you're gonna see that we have a bunch of channels.
It's the big rack system.
Yep, this is the big rack system. So there's a bunch of channels on this one. So there's a few different ways to slim down the files, and there's a few different ways to save it as well. So I'm gonna show each one. So first thing, I noticed that I have a Tryon 3 1820 power. I remember I didn't need these channels. He does not need to view it. So if I want to send it to Rich, for example, and he doesn't have to see this, I can just go under the stored column right here. You see a red indicator, and I can just click that. And you can notice that the channel disappears. So I'm just gonna click a few over here. I noticed that there's an 1850 multi over here. I didn't use this card at all, so I'm gonna click over here, the checkbox, which will select all those channels, and I can just select one of the indicators and it'll remove the whole channel. So I'm just gonna do this for a few different ones that I feel like I don't need, so I can slim down, because there's just a bunch, and it definitely takes up quite a bit of storage because of that. So once I keep doing that, take that away. You know what, this 1850, cut down. So from there,
Now, can you see how many, if you click on the mainframe?
Yep, I was just gonna do that. So when you select the mainframe, you'll be able to see the different channels that you have enabled and disabled right over here. So the ones that are selected in blue are the ones that are enabled, and the rest of them are the ones that we have disabled. So you can see that we removed about pretty much half of the channels that that we didn't want in this. So from there, I'm gonna close this, and I'm gonna go click on the measurement settings button right over here. And over here, you can see the file name, file size, the data that the information that we had prior. Now I'm going to click Save DMD As. So now I'm going to save this as a new name. So I'm going to type in Big System Slim. So I'm going to save that. And now I'm going to open up File Explorer. And one thing you notice between Big System, you're going to see the data right over here. So it's about 1,792 kilobytes, and now we have 802 kilobytes, which is a drastic change, especially if you have days worth of recordings. You are talking between 5 and 10 gigabytes, for example, for a regular data file. Pretty much makes it also easier to transfer it to a colleague, because we know how that goes. File sharing it's not easy to email. So yeah, perfect. So now I'm gonna close this out. And now we're gonna go on to Gunther. Anything on this, Rich?
Yeah, so this is announcing officially our Linux operating system support. We've done it for a while on a number of customers where they did not want a Windows operating system, but now we're just presenting it, and Gunther's our lead software engineer, so he's gonna give you a little background about the thought process.
Perfect. Thanks, Rich. I'm now gonna play the video.
Linux for DEWETRON measurement devices. Why would you use Linux on a measurement device? We personally support Linux because in the software development process itself, the support for multiple operating systems leads to a clear abstraction layer and a clean architecture. The usage of additional development environments increases our robustness and lead to higher source code quality. As a customer, you will be able to use our Linux measurement devices in security-sensitive environments where it's maybe not possible to use a Windows-based system. DEWETRON supports 2 Linux distributions. This is Red Hat Enterprise Linux 8 and the latest Ubuntu LTS. Which devices are supported? DEWETRON supports its full range of measurement devices. So you can use All Trion, and Trion 3 boards, TrionNet, EPAD, CPAD, and DAC-P amplifiers. The Oxygen application, seen here, is fully supported in Linux. Also, you can mix Linux and Windows Oxygen measurement nodes as you like. They are completely compatible to each other. Measurement files are completely compatible, so you can create your setup on your Windows notebook and transfer it to the Linux measurement device and load it there. The same can be said about the DMD measurement files. You can also use the Oxygen SDK to develop Linux plugins. So just look at our GitHub page for documentation and examples. If you have any further questions, please ask our experts.
Ask your sales guy to get to the experts.
Ask the sales guys. Yeah, so that's pretty much all the new features that we have here. So I'll let Rich take over here.
Yeah, thank everyone for joining us this afternoon. Again, the QR code there will link you to our social media sites. And if you can stick around and fill out the survey, that would be great. We want to continue to do these live webinars, and feedback from customers is always welcome. Thank you very much, and have a great afternoon.
Yeah, I'll see you guys. Thank you.